Now, oxidation number is a number given to indicate whether something has received, released, or uh, needs to receive, release, or gain electrons. Okay? Now, the key word that you're going to learn in this chapter is something called redox. Redox means OX stands for oxidation. RED stands for reduction. Okay? So oxidation is when something gains oxygen. Reduction is when something loses oxygen. Oxidation is when something loses electron. Reduction is when something gains electron. Oxidation is when something has a oxidation number increase. And then reduction is when the oxidation number decrease. Okay, so I'm going to teach you how to determine all of this. Are you writing this down? Okay. Let me know when you're
Yes.
done. Okay. Let me know when you're done, okay?
Okay.
Yes. Because it's the currents. What else? Yeah, close to this. Okay, bye-bye. I see you soon. Mommy, help me. I'll go pick you up. Ask Papa whether he has RCIA.
Done.
I'll fetch you back. All right. So, like this. So you see this equation? Okay, which one gains electron? Oh, sorry, which one gains oxygen?
Magnesium.
Magnesium. So because magnesium gains oxygen, we say that magnesium is oxidized. Get it? Can you answer? Okay.
Yeah.
Now, all right. Copper oxide becomes copper. Do you think this is oxidized or reduced?
Reduction.
Reduction. So when you say reduction, you have to say CuO is reduced. You cannot say the product is reduced. You have to say the CuO is reduced. Get it?
Yeah.
Okay. So who is oxidized? Hydrogen.
Hydrogen.
So hydrogen is oxidized. Okay. Okay. Ready?
Wait. Okay.
Okay, so now there's something called oxidizing agent and reducing agent. So oxidizing agent is the one that causes somebody else to be oxidized. Okay.
Okay.
So who causes somebody else to be oxidized?
Oxidizing agent.
Yeah, but who? Which one in this equation? Which one? Which one?
C
Sorry?
CuO.
CuO. So CuO is the oxidizing agent because it oxidizes hydrogen and what happens to itself? It's oxidized or reduce itself
Reduce.
and is reduced. So the one that is reduced is the oxidizing agent. So the one that is oxidized is the reducing agent. So hydrogen is also known as the
Reducing agent.
reducing agent. Okay,
Okay.
can I understand? Okay, so that is in terms of oxidation and reduction. Okay, let's try one more. Can you tell me who is oxidized? Write it down. Who is oxidized? Who is reduced? Who's the oxidizing agent? Who's the reducing agent?
Let me copy first. Okay, so oh, Fe2O3 is the oxidizing agent.
And so it's reduced or oxidized.
Reduce.
Okay.
And then 3CO is the
No need
reducing
3CO, just CO.
CO is the reducing agent, and it is oxidized.
Okay. All right, easy, right?
Yeah.
So that is oxidation in terms of oxygen. So now we're going to talk about redox in terms of electron. Okay, so lose electron oxidation, gain electron reduction. Okay, I'm going to write a few equations. You tell me if they are redox, oxidation, reduction, or redox. Okay. Based on electron, Do you know what I want you to do? Based on electrons,
Hmm. Third
okay,
one, I'm
correct.
not sure.
This one is reduction, correct. This one is oxidation,
Yeah.
correct. Okay, this one, right? What you need to do is like this. This is the this is a ion. This is molecule. This is ion. This is ion. This is molecule, right?
Yeah.
Correct, or not? Right?
Yes.
Okay. Based on both, okay. Can you try and figure out who lost electron?
This one is oxidation.
Who is oxidation?
The reactant.
Which reactant?
AI.
Okay, you see, you look at the whole thing again, This one is K plus, this one is K plus. Did it change at all?
No.
So, no, not redox lah. Okay, here is I negative. I negative change to I2. If this was electrolysis, what would you think this is?
This was electrolysis.
Mm. How would you balance the equation if this was electrolysis?
I negative.
Mhm.
That
If this
means
was
I2
iodide ion in electrolysis,
plus
how would you complete this?
I negative
I
is
negative. Yeah.
I2 plus plus 2E minus.
2I. Right.
Yeah.
This is what happens. So is this oxidation or reduction?
Oxidation.
Okay. What kind of equation is this? Half?
Half.
Half equation. Get it? So
Yeah.
although you cannot see the electron, you can see the electron after you do half equation. Okay, who does reduction then? Who is reduced?
Cl2.
Cl2 become?
Cl2 become
How to write the equation? Ting, ting, ting. It becomes Cl negative, ma. You look at the equation here, it becomes Cl negative.
Cl2 plus 2E minus is 2Cl negative.
Okay, very good. So is this redox? Yes. Can you see who is oxidized and reduced based on electrons? Okay?
Yeah.
Okay. I'm going to give you a few more. You write this down already?
Yes.
Okay, I continue. I'm going to give you a few more. So based on electron transfer, I want you to write down the half equations. Do you understand what I want now? Half equations, So I want you
Okay.
to write down the half equations and then show whether it is redox or not based on electron transfer. Okay? Okay, three equations only. Okay. Uh, okay, correct. Oxidation, reduction, right? Oxidation, reduction, correct. Okay, very good. Okay, so now that is in terms of electrons. Okay, okay. Now, let's look at this. If I give you if I give you FeO and Fe2O3, are they the same thing?
No.
What's the difference?
One is iron oxide, another one is iron 2 oxide. One is
No,
rust.
no, no, not like that. So this one, Fe is Fe2 plus O2 negative, right? Right? Okay. This one is Fe3 plus O2 negative. Do you know why?
No.
This one, this one, the charge of oxygen is 2 negative what? Correct? If the charge of oxygen is 2 negative, and this one is just FeO, doesn't it have to be 2 positive, then can cancel each other out? Right? Okay. And then this one, if this one is Fe2O3, this 2 must have come from above here, and this 3 must have come from above here, like that. You get it?
Yeah.
Okay, another way of counting this is something we call oxidation number. Okay, is Fe2O3 a compound? If it's
Yes.
in a compound, the total of the compound is always 0. Okay, the oxidation number, the total is always 0. And then oxygen in a compound is -2. Okay, oxygen in a compound is -2. Get it?
Yes.
So in terms of FeO, you don't know what is Fe. So Fe is X. You don't know how much is it. Oxygen is -2. Everything add together must equal to 0. So X equals to +2, correct? So we say the oxidation number of iron in FeO is iron 2 oxide is positive. Okay, the oxidation number of iron in iron 2 oxide is +2. So because of that, the name is iron 2 oxide. The name is iron 2 oxide because of the oxidation number of iron. You get it? It's +2. Do you understand? Can?
Yes.
Okay, so in the same concept, can you find the oxidation number of iron in this compound and try and name the compound?
Iron 3 oxide.
Yes, correct. So what's the oxidation number? Positive,
3.
+3. Okay? Can? Do you understand? Oxidation number must be positive or negative, okay?
Miss, if it's negative, do we write iron negative something
No,
oxide?
no, there's no, the ones that you learn the naming, okay? The one that you're naming now is all positive. If it's a negative number, you still put just the number only. But it must be in Roman numbers like that. Can you understand? Okay. Okay, so oxidation number. Okay, so look at this. Okay. If the oxidation number of an uncombined element is zero, that means if I just show you magnesium, just magnesium like that, just sodium like that, just oxygen like that, the oxidation number of all of these is zero. Okay. So as long as it's an element, even though it's O2, it's two of the same atom. It's still an element, the oxidation number is zero. It's only when it's a compound, only it has the oxidation number. Okay. If it is Mg2 plus, then the oxidation number of magnesium is positive 2. Can you see the difference between an atom and an ion? You get it?
Yes.
Okay. And then if it is something like NO3, 1 negative, the total oxidation number is negative 1 because the charge is negative 1. Nitrogen, you don't know how much, is X. Oxygen is negative 2, then there's 3 of it times 3. So X equals to positive 5. So the oxidation number of nitrogen in nitrate ion is positive 5. Can you understand?
Yes.
Okay, I'm going to give you a list. I want you to write down, calculate the oxidation number and write down the name if you can. If you cannot write down the name, just calculate the oxidation number of the ones that I underlined. Can?
Wait, so it's like just now that one iron.
Yeah, I will tell you which one I want you to count. I will underline the one I want you to count. Then you calculate the oxidation number and you try and name it. Okay?
Okay.
Okay.
Okay. Miss, so only need to find the oxidation number of the thing you underline.
Yeah, but you need to find the total only can find.
Yeah.
Remember the total is 0,
Yeah. Algebra.
and then try and name it also, okay? All right. This is copper,
Two
2
oxide.
oxide.
Yeah.
The oxidation number of copper is positive 2. This is positive 1, so this is copper 1
Two.
oxide. So these are transition metals. Only transition metals. This one is just positive 1, and this one is just potassium iodide. Group 1, group 2, group 3 don't have any change in oxidation number.
Okay.
Okay. This one is lead 2 oxide. Oxidation number is positive 2. This one is positive 4. So this is lead 4 oxide, correct?
Yeah.
This silicon is positive 4. This is silicon 4 oxide, otherwise known as sand. What is the number here? Positive 7.
Yeah.
So this is potassium manganate 7. This is going to be your best friend. Okay. This one, hydrogen is positive 1, it's just water. Okay.
Okay.
Okay. Now, you get it?
Yeah.
Let's say carbon plus oxygen becomes carbon dioxide. This is an element. So element is 0. This is also element. So element is 0. Okay? Correct or not?
Uh-huh.
This one is positive 4, right? This one is negative 2. Okay? Correct or not?
Yeah.
So carbon changes from 0 to positive 2. So the oxidation number goes up. So it's oxidation. Get it? Can see it not? From
Yeah.
0 become positive 4. This one, from 0, it becomes negative 2. So the
So reduction.
oxidation number goes down. So it's reduction. Okay. Can you understand?
Yes.
Okay.